So we're going to spend one more day looking at writing systems of equations and then solving the associated problem. The first one says two hopper bottom grain bins are being emptied starting at the same time. 33. The larger bin, holds 45 cubic meters of grain. So that m cubed, cubic meters means we're talking volume. It is emptied at a rate of 1 meter cubed per minute. The smaller bin stores 30 cubic meters of grain and is emptied at a rate of a half a meter per minute, half a cubic meter. We're asked to define variables, model the volume of grain remaining as a function of time using a system of equations. So this basically tells us what our two variables are going to represent. We want to model the volume. So the volume will be one of our variables as a function of time. So that'll be our second piece. So we might start by saying that V is the volume remaining. And T will be the time, and that would have to be in minutes because we are told that the two bins are being emptied at a rate of so many cubic meters per minute. So T will be the time in minutes. So now we'll write our equations, right? The first equation, do you have this booklet, Cherry? So you need to grab it from over on the pile there. We can write this in slope-intercept form. Okay, but first, let's write it according to what we're told. The larger bin starts with 45 cubic meters, and it is being emptied. So it's going to be subtracted by 1 cubic meter per minute. So that'll be 1 T, because T is the time in minutes. In slope-intercept form, we would say negative T plus 45. Negative 1T plus 45. Our second equation for the smaller of the two bins, it starts with 30 cubic meters of grain, and it's being emptied at a rate of half a meter cubed per minute. So it'll be 1/2 T, where again, T is the time in minutes. If we write it in slope-intercept form, it'll be negative 1/2 T plus 30. So there's our two equations that we are going to graph, and then we're going to solve the system of equations. So the first line, negative 1T plus 45. So that has a y-intercept of plus 45, right? That's where the graph starts, at the point 0, 45. Now our slope is negative 1. M is negative 1, which would be negative 1 over 1. But looking at the graph that we have, it's going to be really hard to guess where going down 1 and over 1 will take us. Okay? So we're not going to use down 1 and over 1. We're going to use two other values that have the same value as negative 1. So what I mean by that, the scale along both axes is 10 units. It goes up by 10, 20, 30, 40, 50. And on the bottom, again, it goes up by 10, 20, 30, 40, 50, and so on. I mean, I guess actually we could say the scale is 5. It's just every second line that's labeled. But this first line is actually 5 minutes, then 10, then 15 minutes, then 20. So, knowing that then, instead of going down 1 and over 1, let's go down 5 and over 5. You see, negative 5 over 5 is still negative 1. That has the same value of negative 1. But it's a value that we can put on our graph. We can go down 5 and over 5, down 5 and over 5. And because the grain is constantly being pumped out of the granary, this is continuous data. We can draw a straight line going through. all the way to the end. And the end will be when volume equals 0. You see our axes are already labeled for us, where we have the time in minutes on the bottom and V, the volume remaining, on the side. That's already done for us. If it's not done, then it's something that we always need to make sure that we do. Okay, now the second line has a y-intercept of plus 30. That's where it starts. But the slope of this line is negative a half. And as we said, it's kind of hard to go down 1 and over 2 with the scale that we have. So instead of negative 1 over 2, we can go down 5 and over 10. That is equivalent to negative a half. If you divide top and bottom there by 5, you'll get negative 1 over 2. But this gives us values that we can use quite easily on this grid with the scale that we're given. So from this y-intercept, we're going to go down 5 and over 10. So that's down 1 unit and over 2 units because each unit counts for 5. Down 5 and over 10. 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 So here's our second line. And you can see where the point of intersection is. Remember, that's what we're looking for. The solution to a system of equations is the point of intersection. And that is at the point 30, 15. That's the point of intersection, 30, 15. So interpret the solution. 30 is the x value, which is the time in minutes. So that 30 represents 30 minutes. The y value of 15 is the volume remaining in cubic meters. So that 15 means 15 cubic meters. Both of the granaries have 15 cubic meters at 30 minutes. This is where they both have the same amount of grain remaining. They both have 15 cubic meters. So we can say that both, and what are we calling them here? Both grain bins have 15 meters cubed of grain remaining after 30 minutes. And if you look at what's happening, the first grain bin had more grain, but it's only being emptied at 1 cubic meter per minute. The second one had less grain, and I said that backwards. The first one had more grain, but it's being emptied at a higher rate, 1 meter cube per minute, whereas the second one started with less, but it's also being emptied at a lower rate, only half a meter cube per minute. And so the two lines do intersect. And then after that point, the second bin will have less in it because this part of the graph, the line for the second bin, is lower than the line for the 30 cubic meter bin. Okay, so they empty at different rates, so they do intersect. Initially, the first bin has more, but then after they intersect, then the second bin has more. We also can see, if you look at the time, looks like it takes 45 minutes for that first bin to be emptied, well, it takes 60 minutes for the second bin to be emptied. That's where the volume is 0. Volume's on the left, and that equals 0 when you hit that t-axis. So that's what else these graphs tell us. Okay? So looking at the next one. A movie theater charges $11 for adult tickets, $8 for children's tickets. Suppose 240 people attended. the early movie and ticket sales totaled $2,370. Define variables and set up a system of equations to model this problem. So what we're trying to find out here is how many adults and how many children attended. You've got the price for adults and the price for children. You've got the total number of people that attended, as well how much the ticket sales were. What we don't know is how many adults and how many children attended this movie. That's what our variables will represent. So we might let A equal the number of adults and C equal the number of children. That is what we don't know. So now we'll write our equations. The easiest one to write, it involves the number of people that attended. The number of adults plus the number of children will equal 240. We are told that 240 people attended the movie. There's our first equation. The second equation will deal with how much money was taken in. It's $11 for each adult ticket, and there were A adults that attended the movie. So the money taken in just from adult tickets would be 11A. $11 per ticket times A tickets. Plus $8 for children's tickets, and the number of children we said is C. So 8C will represent the total amount of money taken in just from the children's tickets. $8 per ticket times C tickets. And together that total is $2,370. There's our two equations. Now, if we're going to graph them, normally we put these in slope-intercept form. Normally that's in the form y equals mx plus b. In this case, we don't have variables x and y, we have variables a and c. So I'm just going to choose to get one of them by itself. And it doesn't matter which one you do. Let's say we get a by itself by subtracting c from both sides. So it'll be negative c plus 240. So because I got a by itself in the first equation, I also want to get a by itself in the second equation. So I would start by subtracting the 8c from both sides. It'll become negative 8c on the other side. And I forgot the a with the 11, so we'll do that. And now we will divide everything by 11 to get a by itself for this equation as well. So a will equal negative 8 over 11c plus, then we have to go 2370 divided by 11. To get our y-intercept, which is a decimal, 215.45. And it looks like that 4-5 repeats. Yep. So that's what the line over the 4-5 tells us, that that's a repeating decimal. So there's the equations in slope-intercept form. The first equation has a y-intercept of 240, which we can kind of guesstimate what that will be. That'll be approximately right there, just below 250. But then we have a slope of negative 1, or negative 1 over 1. Well, we can't really do that with the scale that we have, but if we look, we can see that the scale on both axes is 50. On the A ticket, and you know what? I just realized, because they already had the axes labeled, they're saying that the C tickets would be on the y-axis, so I should have had C by itself. I just chose to get A by itself, and that's okay. We'll just change this. We'll say this is the adult tickets. Because I got A by itself, instead of y equals mx plus b, it's C equals ma plus b. So C is the y value. So I'll just change these two around. Sorry, A is the y value. So this is children. Okay, that's no problem. But again, it's hard to go down by 1 and over 1 with the scale that we have. But the scale on both axes is 50. Along the children axis, it's 50, 100, 150, 200. Along the adult axis, it's 50, then they wrote 100. 150, wrote 200. They both have a scale of 50. So we can go down 50 and over 50. We can rise negative 50 and run 50. That's the same thing as negative 1. So down 50 and over 50 is approximately there. Down 50 and over 50 is approximately there. And so on. So we can draw this line. It's going to look something like that. Now, the second line is a little more difficult to do because of what the values are. Okay? So to graph this line, I'm going to use a slightly different method. I'm going to find 3 points that satisfy this equation. Okay? I'm going to randomly choose C values, Jensen, to find out what my corresponding A value will be. Okay? So I'm going to choose some random values for C. Now, if I look at the values of C that I have on my graph here, I'm going to choose 50, 100, and 150. I'm going to choose these three values of C. And see what A value is for each of them. And I'll put these 3 points on my grid and then graph that line. So back to the calculator I go. Now, in this case, my y-intercept is a repeating decimal. So I'm going to store it into memory slot A. So I can grab it back every time I needed it. For each C value, the equation says we need to multiply the C by negative 8 and divide by 11. So negative 8 times 50 is my first C value. Then divided by 11 gives us that value, plus the 215.45 repeating, which I put in memory slot A. So that's approximately 179. So the point 50, 179. So there's 100, 150, 175 would be about right there. 179 just slightly above. So that's that point right there. The next y value or x value I have is 100. So back to the calculator we go. It'll be negative 8 times 100 divided by 11. Plus the y-intercept gives us 143 approximately. So 100, 143 is our next point. 100, there's 100, 150 will be right there, so 143 is just slightly below that. And then our last one will be when C is 150. So it'll be negative 8 times 150 divided by 11 is that value plus our y-intercept, which is approximately 106. So 150, 106, which is just above 100, approximately right there. So now we will draw a line going through all of those points. So that line will look something like that. And the point of intersection appears to be where C, is 100. But to be sure, I'm going to use the graphing calculator in this case. I'm going to put the two equations into the calculator. So in y equals My first equation is negative A is negative C plus 240. But again, we only have one choice for our variable. It's y equals, and then it'll be negative x plus 240. So negative x plus 240. My second equation is negative 8 over 11 times x. So in brackets, I'm going to go negative 8 over 11 to keep that all together, x plus, and it was 215.45, repeating, 45, 45, 45, 45, 45, 45. The more you put in there, the more accurate your answer is going to get. Whatever answer we get here, we're going to round to the nearest integer. So remember, if we go zoom fit, which is zoom 0, the calculator picks the windows for us. And yesterday, every time we did that, we could see the point of intersection. This time we can't. The point of intersection will be somewhere off to the right of this graph, which means we have to make our x max larger. So at the top row here, there's a window key. If I hit that, this is where we can change our x max. I'm going to change it. And if you look at your grid that we have here, our x max should be somewhere over 300. In fact, we can just copy the windows that are on this graph. X could go from, let's say, negative 50 to 350. And the reason I would choose negative 50 is so I can clearly see the y-axis when I graph this. So I'm going to manually input my windows. My x min is going to be negative 50. I'm going to go up to positive 350 for my max, and my scale is 50. So what this means is every tick mark on the graph will count for 50 more children. And then for my y windows, if I look at it, again, I'll start at negative 50, but I'm going to only have to go up to 300, right? Because I just need to be able to see this entire graph. So negative 50 up to 300, and again, I'll set my scale to 50. So now when I graph it, I can see the point of intersection, and I can find it. Second function trace, number 5 for intersect. Enter, enter, enter. And the point of intersection is actually 90, 150. We guessed that it was somewhere around 100, but the graph is off a little bit because of the numbers that we had to graph. So 90, 150 is the actual point of intersection. So again, this is why that graphing calculator is valuable. And it's going to be helpful for you to have one. So either you buy one or also check the library and see if they have any more that can be signed out. So what does this mean? Well, again, 90, the first number, corresponds to the x value, in this case here, the number of children. Whereas the 150 is the y value, which is the number of adults. This tells us there were 90 children and 150 adults at the movie. Okay, that's what that tells us. So again, having that graphing calculator is quite useful in order to make sure that you get the correct point of intersection. Okay, so let's look at this one. During a performance by a theater company, the main act was on stage for 3 minutes less than twice the time of the opening act. Together, the two acts performed for 132 minutes. We want to write a system of linear equations to represent the length of time that each act performed. That's what we're trying to find. So, we need to set up our variables. And the two things that we need to figure out is how long the opening act was. So we can say that let O equal the opening act. And you can choose whatever letters you want for these. And then M equaling the main act. And what we're talking about here is the number of minutes. The number of minutes for each act. That's what we're really calculating here. That's what O will represent, the number of minutes for the opening act, and M would be the number of minutes for the main act. The first equation is easy to write. Together the two acts perform for 132 minutes. So O plus M equals 132. So that one is easy. The second one is going to require a bit more thought. It says the main act was on stage for 3 minutes less than twice the time of the opening act. So the main act M will equal 3 less than twice the time of the opening act. Twice the time of the opening act would be 2O, and then it's 3 minutes less than that. So 2O minus 3. There's our second equation. And because this one already has M by itself, we'll do the same thing with the first equation. We'll get M by itself. By subtracting O from both sides, M will equal negative O plus 132. So again, that's not negative 0, that's negative O. O is the length of the opening act. We want to find the solution and what it represents. We will use our graphing calculator to get this. So in y equals, I'll put the first equation, which is negative x. Again, there is no O variable in our calculator. The only variables we can use are x and y, plus 132. The second equation is 2x take away 3. If I don't change my windows at all, keen, stay with us. If I just hit graph, we see both lines. And we can see the point of intersection. So let's find it. Second function trace, number 5 for intersect, enter, enter, enter. Try that again. Second function trace, number 5 for intersect, enter, enter. And I'll put my guess at around 50. There we go. It's actually at the point 45, 87. That's the point of intersection. The point 45, 87. Which, if we look at our equations, the way we have it set up, M is by itself. Normally it's Y equals, our equation has M equals. So M will be where the Y normally occurs, the second number. That means the first number is O. That is the independent variable. So this means the opening act was 45 minutes, the main act was 87 minutes. That's what this means. Right, that's what that tells us. All right? Two pools start draining at the same time. The larger pool contains 54,675 liters of water and drains at a rate of 25 liters per minute. Smaller pool contains 35,400 liters of water and drains at a rate of 10 liters per minute. Model the draining of the pools algebraically using a system of equations, and then find the solution and describe how it relates to the pools. So the first one, we have to start by choosing our variables. So we might say that A is the amount of water in each pool. And it's being drained at so many liters per minute, so we can say that T is the time in minutes. It's being drained at so many liters per minute. So the second variable will be T, the time in minutes. Our first equation for the first pool, A, the amount remaining. It starts with 54,675 liters, and it's being drained, so the amount goes down by 25 liters every minute, and T is the number of minutes. Now again, if we wrote this in slope-intercept form, it would be negative 25T plus 54,675. Y equals mx plus b is where you have a number in front of the variable. Instead of x, the variable is t. The y-intercept is the constant, 54,675. Our second equation will be for the smaller pool. A, the amount. It starts with 35,400 liters, and it's being drained, so minus 10 liters per minute, so minus 10t. T is the number of minutes. And again, if we write that in slope-intercept form, it'll look like that. We can put both of these equations in our calculator. Negative 25x, whoops, try that again. Negative 25x plus 54,675. The second equation, negative 10x plus 35,400. So both equations are in there. Just do a quick check to make sure the numbers are right and they look good. If you just hit graph, though, you don't see anything because of the windows. We can try zoom fit, zoom 0. Remember, you want to see both lines on the point of intersection. So we can see both lines, but we can't see where they intersect. It's going to be somewhere off to the right. So we need to make our X max larger. So let's change our X max to, I don't know, let's say 1,000. And change our scale to 200. Now when I hit graph, I might have to go further to the right, but I definitely have to go lower. My Y minimum is not low enough. So if I go back to window and I'll set my Y minimum, let's set it at, I don't know, negative 1,000. And set our scale at 5,000. So now when I hit graph, I can almost see the point of intersection. The only other thing I have to do is make my my X max larger, because the graph where they intersect is somewhere to the right of where we see. As you go to the right on the x-axis, your x values get bigger. So we need to make our X max larger. Let's make it 1,500 instead of 1,000. Now we can see that point of intersection. Second function trace, number 5 for intersect, enter, enter, enter. Why is it doing that? Try it again. Second function trace, number 5 for intersect, enter, enter. Let's set my guess at 1,000. And it's actually at 1285 and 22,550. 1285 and 22,550. Just check that. Yeah, 1285 is right. So the variable that's inside the equation is t. Normally that would be x, but now it's t. The variable outside the equation is a. Normally it's y, but in this case it's a. So this means after 1285 minutes, the two pools will have the same amount of water in them. They'll both have 22,550 liters. They'll have the same amount of water, which again is 22,550 liters of water. Okay? Last one. Jamie's traveling with her family from Castlegar, BC to Pincher Creek, Alberta. Her dad and cousin do all of the driving. It's a 440-kilometer trip. It takes 5.25 hours, excluding stops. Jamie's father drives at an average speed of 90 kilometers an hour. Cousin drives at 80 kilometers an hour. We want to write a system of equations to determine the length of time that each person drove. So that's what we need to figure out. So we might let F equal the length in kilometers that the father drives. And maybe C equal the length that the cousin drives. The first equation is fairly simple to write. The total trip is 440 kilometers. So F plus C will equal 440. And we need to get one of the variables by itself. It doesn't matter which one. Let's get F by itself by subtracting C from both sides. That's what it looks like. Our second equation, though, will involve the time. Okay? It takes 4.25 hours. So, to get a formula for, actually, you know what? I did this backwards. I apologize. Because it's the length of time that each person drives. Our first formula should be F plus C equals 5.25 hours. Because F is the length of time that the father drives, and C would be the length of time that the cousin drives. So we should make sure that that's clear. This is the time, which will be in hours. This will be the time in hours. So our first equation will be F plus C equals 5.25. I will get F by itself by subtracting C from both sides. So that's better. Now, the second equation will involve the distance. Okay? So F is the amount of time that the father drives, and he drives at 90 kilometers an hour. So 90F will be the distance that the father drives. 90 kilometers an hour times F hours. Plus, the cousin drives at 80 kilometers an hour. So 80C will represent the distance that the cousin has driven. 80 kilometers an hour for C hours. And altogether, that equals 440 kilometers. Now, in the previous equation, we got F by itself, so we're going to do the same thing here. 90F will equal negative 80C plus 440, right? We subtract the 80C from both sides, and then we divide everything by 90 to get F by itself. And you will have F equals negative 80 over 90, which is 8 over 9, negative, because you can divide those both by 10, C, plus 440 over 90, you can divide them both by 10 and get 44 over 9, which will be a decimal. So our two equations are, the first one is F equals negative C plus 5.25. Our second equation is negative 8 over 9C plus 44 over 9. These are the two equations that we'll put in our calculator. Again, instead of F equals, it's Y equals, and instead of negative C plus 5.25, we have to go negative X plus 5.25. Our second equation would be, in brackets, negative 8 over 9. You want to use the fraction, because negative 8 over 9 is actually negative 0.8 repeating. And you can't really put that in your calculator. Plus, in brackets, 44 over 9. So I'm putting the exact slope in, the exact y-intercept. Now, if I look at these two equations, the first one has a y-intercept of 5.25. The second one has a y-intercept of 44 over 9, which is just around 5 as well. So if I look at my windows, my y max only has to go up to something a little greater than 5. So I'm going to put my y minimum at negative 1, my y maximum at 6, and my scale at 1. Okay? My x values don't need to be this large either, right? So let's go from negative 10 up to, and again, this is our time in hours. We are told the total time, well, actually, let's go 10 hours and a scale of 2. Remember, we want to see both lines and we want to see the point of intersection, which we can. We can see both lines, we can see the point of intersection. Second function trace, number 5 for intersect, enter, enter, enter. 3.25 comma 2 is the point of intersection. Our point of intersection is at 3.25 comma 2. Remember, the variable inside the equation, which in this case is C, is the first number. The variable outside the equation, F, is the second number. This means that the cousin drives for 3.25 hours. The father drives for 2 hours. That's what this means. That gives us our 5.25 total driving time, and that is right. The other thing you can do to check is 3.25, which is how long the cousin drives for, times 80 kilometers an hour, plus 2 hours is how long the father drives for, times 90 kilometers an hour. That should equal our 440 kilometer trip, and it does. It does. So it checks. Okay? So, for practice, 441 to 442, number 5 through 8 and 10. These ones I will post on Google Classroom, those answers, so you can check your work. Remember the assignment from yesterday needs to be handed in for marks. Okay, so you need to get that one done and handed in from yesterday. Pardon me? Yep. Make sure you sign out. Yep.
What time is it?
1:20.